In this complex number session 21, we are going to discuss about problems on multiplication and division of complex numbers in polar form. Let us try to simplify cos pi by 3 plus I sin pi by 3 by cos pi by 4 minus I sin pi by 4. These two are in polar form, but as I told you already in the previous video, I told you in the derivation part, I told you when we are multiplying two complex numbers in polar form or when we are dividing two complex numbers in polar form, they must be in the exact form. That is, real part should be cos, correct. Imaginary part should be sin, yes, correct now. And the term should be plus I between these two terms. But here it is not so in the denominator. Real is in cos, imaginary is in sin, but this is minus I. So we should not keep minus I here. It should be plus I before applying that formula. So let us try to do a small adjustment like this. See, for the numerator we are writing the numerator as it is because it is exactly in the form. But in the denominator, it is not in that form. So let us do one thing. We can write cos of pi by 4 as cos of minus pi by 4. Because you know cos of minus theta is cos theta. Right. Then for sin of minus theta, the formula is different. Sin of minus theta is nothing but minus sin theta. So sin of minus theta is minus sin theta. So if we have minus sin theta, we can write that as sin of minus theta. So for this minus sin of pi by 4, we can write sin of minus pi by 4. Now it becomes plus, because for minus sin pi by 4 alone, we have the formula sin of minus pi by 4. So according to the formula, we have taken minus as well as sin of pi by 4, and it became sin of minus pi by 4. So this minus I becomes plus I. Now these two are in the exact form of polar form. You know, for division of two complex numbers in polar form, we have to subtract the denominator from the numerator's argument. So cos of numerator argument is pi by 3 minus of denominator's argument is minus pi by 4. The same way, plus I into sin of numerator's argument is pi by 3 minus denominator argument is minus pi by 4. So if you simplify these two, our answer will be cos of pi by 3 plus pi by 4 plus I into sin of pi by 3 plus pi by 4. Again, if you simplify by taking LCM, the result will be very simple. That is cos of 7 pi by 12 plus I into sin of 7 pi by 12. So in this problem, we have discussed the division of two complex numbers in polar form with a small change. Instead of plus I in the denominator, we have minus I. That should be corrected first as plus I. After that, we have to apply the rule of division. Right. So I think so you would have understood this. Now let us go to one more sum. Here the problem says simplify 1 minus I by cos of pi by 3 plus I into sin of pi by 3. If you see this problem, the numerator is not in the polar form. So first of all, we have to convert that 1 minus I into polar form. That's our first work. For that, already I told you how to convert a complex number into its polar form. If you have no idea about this, you can go to the video, complex number, I powers and polar form. If you see that, you can understand how we are converting a complex number into its polar form. Right. Now, if we have a complex number z is equal to a plus ib, if we want to convert this complex number into its polar form, first of all, we have to find its modulus value. That is r is equal to root of a square plus b square. After that, we have to find theta, that is argument, that is nothing but tan inverse of b by a. Right. After that, we have to follow this graph. As I told you, whatever the symbol you are receiving here, you don't worry about it. You just treat that as positive and find the principal angle. After that, come to this graph. Just we have to check where our complex number is, whether it is in the first quadrant or in the second quadrant or in the third quadrant or in the fourth quadrant. See this and apply the appropriate formula. Right. So this is the base. As I told you, if you have doubt, you can go to that video. Right. If you find r and theta, then conversion is this: a plus ib is equal to r into cos theta plus I sin theta. Right. Now let us do the problem. Let us try to first convert 1 minus I into polar form. First, let's find r value. R is nothing but real part square plus imaginary part square inside the square root. So our answer will be root 2. Now let us try to find argument or theta. You know the formula for theta is tan inverse of b by a. So if you apply, we'll get the answer is tan inverse of our imaginary part is minus 1 and our real part is plus 1. Tan inverse of minus 1 by 1. If you simplify, it will become tan inverse of 1. As I told you, whether you are receiving negative answer or positive answer, whatever it may be, just ignore this negativity. Simply think this one, tan inverse of 1. For what angle we'll get tan inverse of 1? That is for 45 degree, that is pi by 4. So that answer is pi by 4. Keep it in mind. Now come to this graph where our complex number occurs. It is 1 minus I. That is, our real part is positive and our imaginary part is negative. So come here, real part should be positive and imaginary part should be negative. So it occurs in this fourth quadrant. Formula says that with that angle, what you have received, just add minus. So the angle received by us is 45 degree, that is pi by 4. So the result is now add minus according to this. So your answer will be minus pi by 4. So our theta value is minus pi by 4. So now you know what is r value and you know what is theta value. Now come to this formula. To convert a given complex number a plus ib into its conjugate is nothing but r into cos theta plus I sin theta. So 1 minus I is nothing but root 2 into cos of minus pi by 4 plus I into sine of minus pi by 4. So now 1 minus I is converted into polar form. Now the numerator as well as the denominator are in polar form. So we can proceed now. So if we simplify this, before simplifying this, we must be very careful whether it is in the exact polar form model or not. Yes, real part is with cos, imaginary part is with sine, and both angles should be equal to one another. Moreover, we must have plus I between the two terms. Right. It is both numerator and denominator are in the exact form of polar form. So we can apply the rule. What the rule says, if you want to divide two complex numbers in polar form, then we have to subtract angle. That is, the denominator angle should be subtracted from the numerator. Cos of minus pi by 4 minus pi by 3 plus I into sine of minus pi by 4 minus pi by 3. That is, denominator argument is subtracted from numerator. If we simplify it, we'll get answer like cos of minus 7 pi by 12 plus I into sine of minus 7 pi by 12. It is very easy. You know how to simplify it. Moreover, you know the formula. Cos of minus theta is cos theta and sine of minus theta is minus sine theta. Sometimes if we want, we can simplify like this, because we used to write this in a short form. For cos, we used to take C, and for sine, we used to take S, and for plus I, we used to take I itself. So we can write this as CIS, cis, this angle. That is cis minus 7 pi by 12. That is, if we expand it, that is cos of minus 7 pi by 12 plus I into sine of minus 7 pi by 12. If you want to simplify in another way, you know, formula cos of minus theta is cos theta and sine of minus theta is minus sine theta. So we can write like this. That is cos of minus 7 pi by 12 is 7 pi by 12. For sine of minus theta is minus sine theta. So that is minus I sine this angle 7 pi by 12. Applying this formula, sine of minus theta is nothing but minus sine theta. So this is what the answer. Now let us see one more sum. The first problem we saw, instead of plus I, there was minus I. We changed that minus I into plus I and we proceeded. In the second problem, the numerator was with rectangular form. We have converted that rectangular form into polar form. After that, we have proceeded. Now let us see one more sum. Here, we are going to simplify cos of pi by 3 plus I sine of pi by 3. Numerator is very nice. If you see the denominator has plus I, very nice, but in the real part we have sine and in the imaginary part we have cos. But I told you, for a complex numbers polar form in its exact form, it must have cos in the real part and it must have sine in the imaginary part. So we have to do one thing. The sine should be converted into cos and the cos should be converted into sine in the denominator. Right. So how to do it? You know very well, that is the formula. Sine theta is nothing but cos of 90 minus theta. That is cos of pi by 2 minus theta. So we can write the denominator as cos of, instead of sine, now we can write cos. If you change this as cos, you have to write pi by 2 minus theta, because formula says cos of 90 minus theta is sine theta. So the sine theta is written as cos of 90 minus that angle theta. The same way, for plus I is plus I, cos theta can be written as sine of 90 minus theta. So instead of cos, we can write sine. If we change cos as sine, then we have to write 90 minus theta. Here the theta is pi by 4. So 90 minus pi by 4. That's all. Now the numerator is in the exact form as well as denominator is also in the exact form. Simply we have to simplify this. So if we simplify, the numerator is as it is. The denominator becomes 4. If you take LCM for this, it will be 4. In 4, 2 goes 2 times. So 2 into pi, 2 pi. In 4, 4 goes 1 time, 1 into pi, pi. So if we simplify, we'll get the answer as cos of 2 pi minus pi by 4 plus I into sine of the same way 2 pi minus pi by 4. Right. If we simplify it, the numerator is cos of pi by 3 plus I into sine of pi by 3. The denominator becomes cos pi by 4 plus I into sine of pi by 4, because 2 pi minus pi is pi. Now the numerator is the exact form. In the real we have cos, in the imaginary we have sine and plus I. The denominator is also having with real cos, and in the imaginary part it has sine and plus I. So now it is in the exact polar form. Now we can apply the formula. What the formula says, if you want to divide two complex numbers in polar form, we have to divide their modulus. After that, we have to subtract the argument of denominator from the numerator, that is pi by 3 minus pi by 4. So if you simplify, your answer will be cos of pi by 3 minus pi by 4. The same way for sine. Now if we take LCM, our answer will be equal to cos of 4 pi minus 3 pi by 12. The same way for sine, and our answer will be cos of pi by 12 plus I into sine of pi by 12. So here we have seen three different types of problems. The first problem, instead of plus I, there was minus I. In the second problem, one part is not in the polar form. In the third sum, in the place of real part, we must have cos, but it was sine. In the imaginary part, it should be sine, but it was cos. So these are the three types of the problems you may face difficult. If you understand this, you can do any complex numbers, polar form, multiplication and division. Practice more examples and exercises. Thank you.